Hi, my name is Akshat Maurya, and this is a tutorial on PCA and LDA. As a part of this tutorial, we'll be using Iris dataset. Iris dataset has three classes. One is Iris setosa, second is Iris virginica, and third is Iris versicolor. The Iris dataset has 50 samples of each class. So you can download the Iris dataset from this link. Once you download a file, you'll have a file called iris.csv. It's a comma separated value file, and you can open up this file in either a notepad or an Excel sheet. This file has 5 columns. So the name of the 5 columns are described over here. So the first column is sepal length, the second is sepal width, the third is petal length, and the petal width. So as you can see, there are 150 samples in this data set. So this is the last sample, 150th, and the last column dictates the class of each sample. So this is the sepal length, sepal width is the column B, petal length column C, and the petal width is column D. So let's move on to the Python code that we'll be using. So we'll be using Google Colab to execute our code. In order to execute this code, we need to connect it. So I'll just click the connect button and wait for the virtual machine to connect to our instance. In the meantime, maybe I'll go over the libraries that we are importing. So we are importing pandas library to load the dataset, the Iris dataset, and we are also importing the matplotlib to plot the components of the PCA, and we are importing scikit-learn and again matplotlib. So scikit-learn will be used for PCA and also to standardize the dataset. So as you can see, now our instance is connected with this green tick mark. So let me go ahead and run this cell. So it's running right now, and now it has executed. With this green check mark, we can verify that it has been executed. So let's run the next cell. So in this cell, we are providing the link of the dataset, and we are also providing the name of each column as a list. So we are reading that URL, and we are providing the names of the provided list of the names into the dataset. So print dataset.shape will tell us the shape of this dataset. So as we can see, the first dimension is 150. So that means there are 150 samples, and 5 is the number of columns in this dataset array. So this is a pandas data frame that we have loaded our dataset into. With dataset.head in parentheses 20, it will show us the first 20 examples of the dataset. So first 20 dataset points. So let me just click on it. So as you can see here, it is showing the first 20 samples, since all the first 20 samples were of Iris setosa. So that is why we are seeing the Iris setosa class. Okay. So let's move on to the next cell. Next cell defines the features. So what are the features that we want to use from this dataset, right? As recall from this dataset that we have 5 columns in it, but we only need first 4 columns to perform the PCA. We don't need the class information for PCA. So we'll be constructing a new list called features, and we'll be storing all the columns that we want. So sepal length, sepal width, and petal length and petal width. We'll slice this pandas data frame. So will select all the rows and these columns that are specified by the features list, and we're returning dot values. The dot values will return a numpy array into an X. Similarly, what we are doing is we are storing the class, so the last column class, into a different variable y. So I'm going to run this cell now. So after that, I'll print first 20 dataset points that have been stored in X. So you can verify that the first 20 dataset points are actually the same that were present in the dataset in the pandas data frame, right? So the first row 5.1, 3.5, 1.4 and 0.2 is the same as this row. So all that we have done is we have sliced our pandas data frame and converted it into a numpy ND array. So next, we are using standard scaler to standardize datasets features. The standard scaler will reduce the feature-wise mean and divide the dataset by standard deviation of the features. So let me go ahead and run this cell. So as you can see, our dataset values are now 0 mean, and their standard deviation should be, their variance should be 1. We plan on projecting these 4 features in a 2-dimensional space. So we are constructing a PCA object. We'll pass n components as 2 and we'll get a PCA object. From there on, we will call fit transform on our dataset X. So it will return the principal components. So all the projected points, it will return it in a principal components object. So let me go ahead and run this cell. So here what we are doing is we are constructing a data frame from our principal components, and the column names will be component 1 and component 2. So any arbitrary name will do here, and then we are concatenating our components, so this data frame that we got, with the class information of each of the row. So let me go ahead and run this cell. Let us visualize the first 20 samples of this final DF data frame. So as you can see, the first and second column is the intercept of the projected data points. So this is the component 1 and this is the component 2, and the third column is the class label of the corresponding sample. So in order to plot this projected data points, we'll be using matplotlib. In the first line, we are constructing a figure. The figure will be of size 8 by 8, and we are adding a subplot to it. It will return an axis. On this axis, we are setting the X label and Y label, component 1 and component 2. Then after that, we are setting the title of this figure. Then we are sort of specifying the class labels in the targets and colors of these class label as a list. Target is a list and colors is a list, and R will be the color of iris setosa, G will be the color of iris versicolor, and B is for blue, will be the color of iris virginica, so red, green, blue. We are iterating over the targets and color with the zip. So zip will return one element from targets and one element from color. First iteration will return iris setosa and R in the target and color. Then we are masking this final data frame. So wherever the class is equal to the target, So let's say in the first iteration target is iris setosa. So wherever the class is equal to iris setosa, we'll keep it into a boolean array as indices to keep. Afterwards, we are using this boolean indexing in our final data frame. We are passing this boolean sort of boolean mask and the column that we want to print, component 1. Similarly, indices to keep the same mask and component 2, and C equal to color, so the color that we got from the iteration, and S is equal to 50. That means the number of points that we need to scatter. So there are 50 points for each class, so that's why S is equal to 50. Then we are using ax.legend to sort of plot this data set, and then ax.grid to turn on this grid. So let me go ahead and run this cell. So as you can see, we have projected our data set. Here the legend is printed: iris setosa, iris versicolor, and iris virginica. The blue points sort of belong to iris virginica, and iris versicolor is in the green point. So we can see that PCA is not able to separate iris versicolor and iris virginica class. So next we are using LDA. We are importing linear discriminant analysis package from scikit-learn. We are also importing label encoder from scikit-learn. This label encoder will convert our class names into an integer value. Again, we are saving this class names of the column that we had in final data frame to a y variable, and then from there on we are converting this y values to an integer value. This label encoder transform will actually convert these class values to an integer value, and we are adding 1 so that we don't get a 0 in our class value. So here we are printing randomly 10 values from our class from this y variable. So next we are constructing a linear discriminant analysis object. We are passing n components as 2 because we'll be projecting it into a 2-dimensional space. After that we are calling fit. So LDA fit x comma y. It will fit this x data set, and y is the label of those x data set, the points that are in the x, and then from there on we are transforming. So this dot transform will perform the will get us the component of the points in the 2D space. So let me just run this cell. After that we are again forming a data frame. This time we are naming the components again as component 1 and component 2, and we are also concatenating these columns with the class variable. So whatever the name of the class will be for each point, it will be concatenated alongside it. So from there on we are again constructing a figure like how we did it in PCA. So this entire code is exactly same as the PCA. So I'm just going to run this cell. So here we get a LDA in 2D space. So we can see that LDA is able to sort of classify, to construct a linear classifier. So it is able to separate the 3 classes into sort of 3 regions in a 2D plane. So this concludes our tutorial. If you have any doubts, I'll be happy to answer them over Google Classrooms. Thank you.